This video is going to go over graphing quadratic functions, and these quadratic functions look something like this equation that you see here. Y equals some number x squared plus some number x plus a constant. A quadratic function is going to give you one of two different kinds of graphs. The one you see on the left would be an upward facing parabola, and it's upward facing because the number in front of the x squared is a positive number. On the other hand, on the right side, we see a downward facing parabola, and that is because the number in front of the x squared is a negative number. So keep in mind it could be upward facing if that first number is a positive, or downward facing if it's a negative. Before we actually start graphing a parabola, I want to give you some vocabulary terms to help you be more familiar of the different parts of a parabola. So the first would be the vertex, and the vertex is the point where the graph changes direction. So if you look down at the bottom on the left-hand side graph, the vertex is going to be here at the bottom. And on the right side of the graph, that's going to be at the top. It's where the graph changes from going up to going down. The axis or line of symmetry is a vertical line that divides the parabola into mirror images, so it kind of splits it in half. And it's a vertical line that goes through the vertex. So the axis or line of symmetry would be a line that goes straight up and down through the vertex. And we'll write that as an equation that's x equals, and it's whatever number that it crosses on the x-axis. So it could be x equals -1, x equals +4, whatever value that's crossing on the x-axis. And we also have a maximum and a minimum. So on the left side of your screen, on that left side graph, this is going to have a minimum because it's the lowest point on the parabola. But on the right side graph, this is the tallest point of the graph, so that is called the maximum. The last set of vocabulary terms you need to know are zeros, x-intercepts, and solutions. And those are all different words of saying the same thing. It's telling you where the graph is crossing the x-axis. So for quadratic functions that we're doing with this video, there are going to be two, because each parabola is going to cross the x-axis at 2 points. Sometimes it won't cross at all, and you would not have any zeros or x-intercepts or solutions, but if you do, that's where you find them. Okay, let's go ahead and graph this quadratic function. Y equals 3x squared plus 6x minus 3. The first thing we're going to do is to find the vertex, and I'm going to show you a unique little formula that helps you find the x-coordinate of the vertex. It is x equals the opposite of b over 2 times a. And if you remember back to the quadratic formula, there's certain places where we find these letters a, b, and c. A is the number in front of the x squared. So a is +3. B is the number in front of the x, which is a +6. And c is the number found at the end. In this case is -3. So there's where I'm going to find a and b for this formula. So x is equal to the opposite of b. So the opposite of a +6 is a -6. On the bottom we've got 2 times a, which in this case is 3. Now if we simplify that, we'll have negative 6 over positive 6, which is equal to negative 1. So we know the x-coordinate of our vertex is going to be negative 1. So now we need to find the y-coordinate of the vertex. And to do that, we're going to take the original equation, y equals 3x squared plus 6x minus 3. And now we know that x is equal to negative 1 for the vertex. We can plug a negative 1 for all the x's and solve it to help us find the y-coordinate. So we're going to replace all of the x's with negative 1. And let's simplify this. So remember that exponents come before multiplying, so the 3 stays for now. Negative 1 squared is positive 1. And then let's multiply. 3 times 1 is positive 3. Positive 6 times a negative 1 is a negative 6. And then we bring down the negative 3. 3 minus 6 is negative 3. Minus another 3 would be negative 6. So the y-coordinate of the vertex is negative 6. And we would write the vertex as the ordered pair. Remember, x comes first, so negative 1, comma, negative 6. That's going to be the first point that we put on our graph. So we found the vertex. It was at negative 1, negative 6. So that's going to be the first point that we put on our graph. Negative 1, negative 6 would go right here. Since this function has an a value of a positive 3, I know this is going to be upward facing. So this is going to be the lowest point on our graph, which means it's going to be the minimum. So I know the minimum value of this graph is negative 6. I also know that it has a line of symmetry that's vertical through the vertex. So the line of symmetry I'm going to just draw as a dotted line. And that goes through the x-axis at negative 1. So the line of symmetry is x equals negative 1. Now we just need to find at what points do both sides of the graph go up from the vertex. So to do that, I'm going to choose the next point either to the left or to the right. I'm going to choose to go to the right first. So it goes through negative 1 on the x-axis, so that means the next x-coordinate to the right would be 0. So just like we did to find the y-coordinate of the vertex, we're going to plug x in, or we're going to plug 0 in for all of the x's in the original equation. So 3 times 0 squared plus 6 times 0 minus 3. And we just simplify this. Remember, we do exponents first, so 0 squared is still 0. 3 times 0 is 0. 6 times 0 is 0. 0 plus 0 is 0, but then minus 3 would give us a y of negative 3. So that ordered pair would be 0, since that's what I put in for x, and then negative 3 that I got for y. So 0, negative 3 would go right here. Now let's see what would happen if I chose the next point to the left, and that would be negative 2. So I'm going to take the same equation again, and I'm going to plug in a negative 2 for all the x's. So So negative 2 squared is a positive 4. And 3 times 4 is 12. A positive 6 times a negative 2 is a negative 12. And 12 minus 12 is 0. Minus 3 is negative 3. So if you see, I'm going to get the same y value from one point to the left of the line of symmetry and one point to the right of it. So this time this ordered pair is going to start with a negative 2, since that's what I plugged in for the x's. And then I got negative 3 for the y. And I'm going to graph that point as well. So negative 2, negative 3 would go right there. Okay, so now we have 3 points, and some people might want to stop there, but that's not really a good place to stop. Let's see if we can find some more points. So here's our graph so far with our 3 points that we found, and let's find at least a couple more. Let's go one more on either side of the vertex. So we chose negative 1 as the vertex, and then we chose 0 as the next x-coordinate. And let's go over to positive 1. So in our original equation, we're going to plug in a positive 1 for each of the x's. Okay, remember to do exponents first. So 1 squared is 1. And then multiply. 3 times 1 is 3. 6 times 1 is positive 6. 3 plus 6 is 9, minus 3 is a positive 6. So this ordered pair would be 1, since that's what we plugged in for x, comma 6, because that's what we got for y, and then graph. Go way up here. And let's find one more on the left side. So we had done negative 1, negative 2, and now let's plug in a negative 3 for the x. Exponents first would be 3 times 9. Three times 9 is 27. 6 times negative 3 is negative 18. And then 27 minus 18 is 9, minus another 3 is a positive 6. So again, we're getting the same y value. The x is negative 3, the y is positive 6. And graph that. Go right up top. So remember, our line of symmetry was that x equals negative 1. And if you look, that splits our parabola right in half, and it's a mirror on both sides, meaning all the points are the same distance away from the line of symmetry. So to finish up the graph, we're going to connect all of the dots. They're not going to be straight lines. It's going to be a curved line, kind of like a U shape. So we're just going to do the best that we can to make it not a point at the bottom, but rather a U shape. And put arrows on the ends. And your graph is complete.